Hello and welcome to this video about the volume of prisms. The learning target for this lesson is finding the volume of triangular and rectangular prisms. So let's talk about prisms. Prisms are essentially just a fancy phrase for a 3D shape. And so what that means is that we're adding we have three dimensions all together. Now our line in the sand is what we're going to focus on are triangular prisms and then rectangular prisms. Now, let's start off with the rectangular prism. They could be something like a cube that look like this right here, where each one of these sides is the exact same measure. So they all have the same measurement. Or they could be stuff where they're not necessarily the same size. So it could look like this. And so this would be our rectangular prism. Two of the sides might be the same and the third one might be different, or all three might be different. But the big thing we have to take from this is that we have a length, a width, and we have a height. Now, sometimes these variables get interchanged, because if we wanted to, we could say length, width, and depth. But the thing is, we have three variables that we're talking about, or three dimensions that we're talking about, and they all come together to help us form the volume. Now, let's talk about the triangular prism. Triangular prism is where one face of it is a triangle. So I think this might be the best way to kind of visualize it. We start off with a triangle, and we go back there like that. Perfect. And so that's a triangular prism where, again, we have at least one face, in this case two faces, will always be two faces, is a triangle, but then everything else is a rectangle. Okay, and you can kind of see that here, like this side is a rectangle, the bottom part would be a rectangle, and this back part is also a rectangle. So those are the two types of prisms that we have, and that's leading to our core idea here. So, big core idea I want you to take from this is that volume is equal to base area times, let's just call it height. Now again, sometimes we might call it depth, we might call it something else, but it is a base area times that third and final dimension. Now when it comes to rectangular prisms, our volume is going to be equal to length times width times height, or depth, again, whatever variables you want to use there. But where it gets a little more complicated is when we talk about the volume of a triangular prism. And so that's where we're going to take this idea of the base area times our third dimension. Now let's kind of illustrate this, and so we can see what I'm talking about here. So let's say that we have a rectangular prism like this. Now when we're saying base area, I'm talking about like this face. If we know the area of this, we have to times it by that final dimension there. And because essentially what's happening is we're just adding them all up. We're multiplying how many of these there are. When we have a triangular prism, so let's draw another one, so like this. If we know the area of this triangle, that triangle is being repeated and repeated and repeated throughout this whole thing. So we just have to multiply this area by however long that dimension is. And so as long as we have the area of one of the bases multiplied by that third dimension, we've found the volume. Now with this being said, volume is always going to be given in units cubed because you have three dimensions: length, width, height, or depth, whatever you want to call it. So now enough yakking about this, and let's look at some examples. Scroll up to the top. Here we go. So we're going to find the volume of these. And what I like about this is here I'm showing you these numbers might not always be clean. All right, you might have to deal with some fractions. So the volume of a rectangular prism is just our three dimensions multiplied together. Now in a situation like this, I'd recommend taking this number and turning it into an improper fraction. So volume is equal to 5, I use a lot of parentheses here, times, now 10 and a half is 21 over 2, times that by 8. Now here we have a couple of options. I could what I'm going to do though is multiply these two together. So 8 and 2 reduce to 4 and 1. And now to make my life maybe a little bit easier, I don't know if this will actually make it easier, I'll do 5 times 4, which is 20, and then I'm left with that 21 up there. Multiply these together, and we get 420 units cubed. And that is the volume of this thing. So again, all we did is we multiplied them together, but what I did is I converted this to 21 over 2 to make life a little bit easier there. Now, let's look at a second example. Here, we have a triangular prism. So my plan for the volume for this guy, the triangular prism, is I want to take my base area, B, little subscript A there, times it by, in this case, I'll call it depth, this other dimension, how far back it's going. So right here, be careful. All right, sometimes you might be given a right triangle, but here I have this information that's telling me that my height is 6 and that my base is 13. So I have 1/2, my base is 13, so 13 times 6, and I'm going to times all of that by 10, which is the depth. Now let me play around with this a little bit here. So 1/2 times 6 is 3, so 3 times 13, times that by 10, excuse me, we get 39 times 10, and that equals 390 units cubed. And there we go. And so for this one, I had to have that height in order to figure out the base area, the triangle, and then multiply by the rest right there. Moving on, let's do one where there's no picture. All right? We don't necessarily need a picture. We can just deal with the numbers. And here we have lots of fractions. So again, I'm going to recommend that if we are told that we're given these numbers, it's safe to assume that what we have is a rectangular prism and that we have to find its volume. So we're going to go with length times width times height. So now I'll convert these on the fly. So 2 1/3 becomes 7 over 3 times 1 1/2 is going to be 3 over 2 times 2 2/3 is 5, or 1 2/3 I should say, sorry, is 5 over 3. Now I can start seeing if any of the numbers want to cancel out. This 3 and this 3 will work, and then everything else kind of stays the same. So I'll have 5 times 7, which is 35, and then 2 times 3 is 6. So I could leave it like that, walk away. If I wanted to, I could make it a mixed number, and so this would be 5 and 5, 6 units cubed. So whatever floats your boat there. And so that is how we go about finding the volume of these different prisms, rectangular or triangular. Now, let's talk about how to find missing dimensions. So with missing dimensions, the big thing that we're going to do here is we're going to solve. Previously, we were essentially evaluating, taking a bunch of numbers, and we were just multiplying them all out. Here, though, we need to solve. So with a triangular prism, I'm told that its volume is 24, and that its area, the base area, the area of the triangle, is 3. Meaning, I need to figure out what that is. So remember, volume is equal to base area times height. And so what I'll do is I'll take 24 is equal to 3 times my unknown, which is h, and now I have an equation in which I need to solve. So if I want to get h all by itself, I'll divide by 3. I have a mirror line going on, so I should probably divide the other side by 3 as well. And as a result, I have 8 is equal to h. My height is equal to 8. And this will be regular old units. Now, let's do another one, but this time we have a rectangular prism, and we're just given the numbers here. So volume, and let's just kind of put a little r there so we know it's a rectangular prism. All right, this one's going to be a fun one. So again, volume is equal to length times width times height. Plug in what we have. So we have 36 is equal to 6 times 4 times h. And to be honest, it doesn't matter where all of these numbers go in terms of these things, because we're multiplying them all together. And again, we could just pick up this rectangular prism, flip it on its side, and the numbers don't change. It's just sort of what we're calling them changes. So that doesn't matter too much. Anywho, go about solving. So here we have 36 is equal to 24 times h. Divide both sides by, whoops, not 20 or h, but by 24. And here it's okay. Like, we're going to get sort of a weird answer. We're going to get h is equal to 36 over 24, but that can be reduced to 3 over 2 after we take a 12 out from each of those. And so sometimes, again, our answers might not be whole numbers, and that's fine. 3 over 2 is an acceptable answer there. And that's how we would find some missing dimensions for volume problems. So we now have all the basic tools that we need for all these volume problems, whether it be finding it for rectangular and triangular prisms, or using the volume to find missing dimensions. Good luck on your homework or practice, and let me know if you have any other questions.